Hi, I'm Jeff Barr. As Chief Evangelist for AWS, I'm tasked with understanding and explaining our web services, what they are, what they do, and how you can put them to use.
Hi there, I'm Tim Bray, and I'm an engineer at Amazon working on, among other things, messaging services. And the reason we're here for this series is to explain about messaging services, why you need them, and how to use them, and which ones there are, and what the differences are, and how to pick. But let's start with some history. You know, I used to do what you do. For 10 years, I was a public-facing person at Sun. That's right.
This Sun.
I helped build the Sun Cloud. Everybody using the Sun Cloud out there? Anyhow, so I was a public-facing person, and I think we ran across each other in 2004 or 2005 or something.
I actually think you emailed me once, and I'm not 100% sure
Yeah,
that
on
I
the
ever
screen there,
replied.
there's an email when I was trying to rally the forces of the anti-WS star revolution.
I guess you succeeded.
Even though you didn't answer. That's right. So I was hired there at Sun, you know, partly because I was a blogger, and that was a radical new thing. So Jeff and I were kind of in the very first wave, maybe the first like 4 or 5 corporate bloggers in the world. Yeah.
Absolutely, for sure. So even before I came to Amazon, I really thought a lot about applications that had some kind of extensibility component, scripting, and then add-ons and plugins, and then in my own internal logic, that actually led me to a point of thinking that web services were the way to do that. And so thinking back just not so long ago, probably at the point of that email, just getting 2 applications to talk to each other was a genuinely big deal.
Right, and one particular thing you did was, as a consequence of that, was you wrote this blog in 13th of July, 2006, introducing Simple Queue Service. Now, back in those days, the hot stuff was Corba and DCOM and WS Star. So this was, I mean, when I saw it, I say, oh yeah, I see how you could use that, but it was really a pretty new thing in the world. So how weird did it get? I mean, did people get the idea?
They actually really did, and you know, I look back on that blog post with a lot of affection, because I think about those early services and how complicated they were, and we were very deliberate about putting that simple at the beginning of the name. And then thinking back to how we launched that, we didn't go to any great lengths to make a lot of noise about what we did. We were very direct, honest, straightforward. Simply said, here's a service, this is what we called it, this is what it does, this is what we suggest you use it for, here's the APIs, here's the pricing model, here's a brief overview of some thoughts on the service, and just simply invite developers to have at it. And at that point, when we launched SQS, we were well underway with EC2 and S3, and we were thinking about databases, we're thinking about networking, we've got lots and lots of plans, and we were certainly using the phrase cloud computing, but we didn't feel compelled to roll out a roadmap. We didn't think that we need to say, we are now ushering in a brand new era and we're about to change the world and stand back, here we come. We simply said, here's a message queuing service, and we sincerely hope that you find it useful. And I suspect people looked at that first announcement and they said, why is my bookstore selling me message queuing? This just makes a negative amount of sense, but nevertheless, developers found it and they took to it very, very quickly.
And you know, and to this day, when there's something new in the world and I want to find out what the details are about what it really does, I go to blogs. Blogs are the places where you find that kind of stuff. Well, anyhow, since 2006, we've come really a long way. We've got 6 messaging services now, because messaging is really a big deal for our customers. Some of these ones are running super hot. Like, for example, on Prime Day, a couple of these are running at over 1 million messages per second. And I don't mean just 1 or 2 million messages a second. I mean really, really super hot. So let's start diving in and talking about these things. But folks, this is Twitch. It's supposed to be interactive. So feel free to hop on Twitch and send us any questions, and we'll glance occasionally and see if there's anything juicy. But you know, don't try and embarrass us. Our combined age is well over 100 years. You know, it's not going to work. Okay, so let's start at the beginning. Why do you need messaging stuff at all? And we're not going to talk about the theory of messaging. We're not going to talk that much about APIs. We're going to talk about use cases. And Jeff, I think you might have a use case in mind.
I think so. So not everybody knows this, but we actually have this online store that sells things. Did you know that?
Really? Wow.
It's actually pretty cool. You can order stuff on your computer and it shows up on your doorstep, sometimes even the same day. So it's actually pretty cool. So we have this store. So you go to the website and you find something that you need. You click on buy, and a lot of things actually happen behind the scenes. So a couple of those are really quick. We validate your credit card, we verify that everything's in good shape, and we actually place your order. But then behind the scenes, there's a lot of processes that get kicked off that might take hours or days to really play out. So the website cannot effectively make a synchronous call to your code and just sit there hanging, waiting for things to be pulled off of shelves and put in boxes, and for a truck to roll, and for something to show up on your doorstep.
None of those things on the screen happen in microseconds.
No, those are very, very long-running physical processes, and the idea of this deep, deep stack of function calls just is not the way you'd want to do things. Everything's just too tightly wound up together. You can't have the website just sitting there. So instead what happens is that there's a lot of messaging behind the scenes. We validate your order, we make sure your credit card's good, we put together a little message packet with your order, drop it in a queue, and off it goes to the next service down the line.
And then the front end forgets about it.
Front end forgets about it. The website says, thank you so much, Tim, for your order. And it goes on its merry way. Behind the scenes, lots and lots of things start happening as a result.
And eventually the back end will pick it up and start moving those boxes.
Exactly. So on the back end, we've got databases, we've got fulfillment centers, we've got trucks, all these things running more at physical speed, running a lot more slowly.
And the fact that they're running at different speeds is okay.
That's the whole idea of when you start to talk to a distributed architect, a distributed systems architect, it's all about loose coupling and saying, we've got these variably sized buffers between all the parts, and if the producer's running really, really fast and things start to pile up in that buffer, no big deal.
I've actually seen some of our live queues with over 1 billion messages sitting in them. And they're all stored in different AZs with physically separated and so on. So once it's on the queue, you're probably not going to lose it.
Yeah, it's just going to be saved up. And it's actually interesting around here. Powers of 10 kind of lose their significance pretty easily, don't they?
That's right. And so the point is that if the back end is running a lot slower than the front end, which is on Prime Day, well, maybe there'll be like hours of orders build up in there, and it'll take 5, 6, 12 hours to clear out the queue, and that's okay. That's what queues are for. Maybe it's not a coincidence that the first managed queuing service spun up about the same time as retail.
I don't think so. The fact that we've got all these messages across different availability zones, highly durable. We do not want to lose a customer order. Absolutely not. So we engineer durability into SQS, for example, make sure that order is scattered out across several different availability zones, hold on to it, keep it safe and sound. So a lot of our services very pointedly do have the word simple in their name. I think at first people might have thought simple meaning, well, there's not a whole lot to the implementation if it's the simple storage service or simple queue service. But to me, simplicity is more about the mental model and the programming model. So we should talk about that a bit.
Right. So I thought we'd do a little short demo here. And the demo we're going to do is using SQS just because it's the oldest of our services. And let me just hop over to my blog, which is sitting, I think, in Toronto. I actually don't know where that computer is. That's actually not on the cloud. Oops, dear. Anyhow, but since it's a blog,
cool. Let's make sure we get Tim's screen up on
let's have some
Twitch.
look at the screen. So here's I'm just doing a tail on the Apache log file, and there's all sorts of stuff happening there. And even if I haven't published anything recently, there's all sorts of crawlers and so on hitting the log file all the time. So what I've got here is I have a little Ruby script. Ruby's my choice. It may not be yours, but it's mine. And so I just want to show you how you actually send some stuff. So first of all, I have to say I'm running in US East 1, and then I need to make a new queue. And interestingly, this is one of our latest and greatest FIFO queues. So you can be confident that the messages come off the queue in the same order they went in. And I've also turned on content-based deduplication. So if I say send the same one twice, it'll just drop one. And in this particular case, anybody who knows anything about Apache log files will know that, some of these lines will be the same and thus get dropped. OK, so then I go and I get the queue. And then what I do is I just read each one and set some attributes on it, and then eventually I send the message. And I keep count, and every 10 messages I say how many succeeded and how many failed. So let's just run that. I'll run that tail, and I'll put it into, OK. So now all those are being sent off. So let's go back to my computer here. This one's running on my real computer right here on Amazon. Oh, there. So it sent the first 10 and hasn't had any failures. And let's go back here, and here's the the Ruby script that reads it, it's even simpler. It just says, go to East 1, and there's the name of the FIFO queue, and then down here at the bottom it says, read each message and print it up.
So very, very little in the way of overhead or setup or configuration.
It's the world's simplest API. So Ruby simplifies things. At the very bottom level, you send messages, you receive messages, you delete messages. Anyhow, now you may have noticed that I've been sending messages into that queue while Jeff and I have been chatting here, so there'll probably be a few built up there. So I'll just say, let's run that, and there'll be the messages coming in from the other end. At the other end, we've put 120 messages into the queue, so those ones will go by pretty quick. And then eventually it'll slow down and run more or less at the same speed. So those messages are going from my blog server, which is off in Toronto, to SQS and US East 1, and then back over the Corp network here to Seattle. And the latency is pretty good.
But you could scale this to hundreds of messages a second and multiple producers and or multiple consumers.
Absolutely. In fact, these days it's fashionable to talk about serverless. And SQS is kind of the original serverless thing. You don't have to reserve any capacity. You don't have to do anything in advance. You just say, here's some messages. And if you want to run it 10 test messages per second and then suddenly switch to 100,000 messages per second, that's fine.
And that was so obvious we didn't even point that out back in 2006.
Huh, that's right. I mean, the description was thin, but people who were already building distributed systems got it right away.
They absolutely did.
I think. So I should probably shut this thing down and
yeah, because we're up to almost a micro penny worth of cost there.
That's right. And go back to this. Okay, so there's the demo. What were we going to talk about next?
Okay, so you have used the word services, plural. So why different services?
6 different services. Well, in fact, there's 1 or 2 others you can use for sending messages. So it is, in fact, more than just 6. And in fact, if you go to aws.amazon.com/messaging, they're all limited. They're all listed there, and there's use cases, and you can go off to descriptions of them. But we do it the way we always do it at Amazon. We work backwards. We go talk to customers, find out what their problems are, and then build stuff to try and address their problems. And it turns out that you think that something as simple as sending messages and receiving messages. No, it's not that simple. There's lots of different patterns and uses and ways you need to do it.
It's actually really interesting how this speciates over time, where we started out with a simple, effectively one-size-fits-all model, and then from hearing from more customers and hearing about their use cases, something said, let's add more features to SQS and let's add more capabilities. But some of these evolutionary pressures, if you will, were big enough that really said, let's actually create a totally separate branch, and we need to solve the customer challenge with not a variation of a service, but something totally different.
Yeah, no, that's what that series is all about. Because, to be fair, when somebody first comes in to do messaging, this might be a little intimidating. Figure out which one you're gonna do. Now, I could go into buzzword bingo and talk about pub sub and filtering and dead letter queues and AMQP and MQTT and NMS and JMS and so on, and we'll do some of that stuff.
So there's a couple different ways that you can look at this, and I know that there's a somewhat business-oriented point of view that really says there's a gigantic difference between messages and events and notifications. For example, Clemens Vasters from Microsoft, he really talks about some philosophical
we're not
differences.
Supposed to talk about competitors.
Yeah, but he actually does talk a lot about AWS, and it's a good talk, and I would actually recommend it.
Yeah, well, let me tell you a funny story about that. Months and months ago, we first really noticed that there was an issue about all these services and explaining the differences. So they put together a working group full of general managers and product managers to figure out, how do we talk about this to customers? And they went and started talking about these abstract things about messages versus notifications and the business dimensions, and it took them quite a while. Simultaneously, I got together with a couple of the senior engineers from the other messaging services, and we sent some emails around. In about 3 hours, we had a nice complete description of what the exact API differences were and what the semantics of sending and receiving were, and we thought the job was done. But, that's all there online. But, the business issues really do matter.
They really do. So what we want to do over the coming weeks, we want to really start telling some really good stories. So for each of those services, we're going to zero in on a couple of customers. We're going to dive into what the customers are doing with just a couple of the messaging services. We're going to show our audience code samples, design diagrams. We're going to have them share some actual war stories from using these different services.
We'll talk about particular customers.
Absolutely, for sure. Let's see. So a week from today, on May 10th, we've got Amazon MQ. The talk will be called Messaging for Migration and Modernization. So along with Tim, you'll have Trevor Dick, who's the Senior Product Manager for Amazon MQ, and we'll have Brock Miramontes, who's the CTO and co-founder of Crew. Apparently they use message brokers quite heavily in their chat app, and he's also an active MQ expert.
Yeah, so ActiveMQ is, I mentioned it because it's actually, Amazon MQ is actually a hosted version of this open source package. And by the way, if you're using it and have questions, Brock is like a heavy expert at ActiveMQ, way more so than I am.
Hopefully we actually sell that book on Amazon.com.
We sell every book on Amazon.com, I assume. And so from the technical point of view, Amazon MQ, based on ActiveMQ, isn't like your typical managed service. It's more like RDS, which is we host the open source broker on an instance, and you get to run it. And unlike a lot of services, it's not a RESTful interface. The way it works is you nail up a TCP/IP connection to it, and you talk a protocol like AMQP or something like it, which means that you can get fantastically low latency. The reason we chose it is because there's a lot of open source message brokers out there, but it has a really good compatibility story. It can talk AMQP and MQTT and Stomp. I have no idea what Stomp is, and JMS and NMS and lots of others. And there's a lot of people out there who are transitioning from their on-prem messaging stuff to the cloud. And you're probably using one or more of those APIs and protocols. And if you're doing that, then MQ is totally the way to go to get on the cloud with the minimum amount of pain.
All right, so May 10th was MQ, and then May 17th, we're going to talk about SNS. That session will be called Messaging for Parallel Processing. And joining Tim will be Sam Dengler, who's an AWS solution architect, and he lives and breathes notifications and messages.
That's right. And our customer will be Play On Sports. That's right, high school sports. They're a leading service for sharing your high school sports footage with fans and followers and mom and dad and the grandparents.
Throw this at the camera, what happens?
It's a nice business. And obviously, they're all about fanning stuff out. So SNS is a fully managed messaging service like SQS, but it's PubSub, which is you make a topic and you push things to a topic, and then the topic can fan out literally 1,000 wide, more if you want, to SQS queues, to Lambdas, to arbitrary REST endpoints, to simple email service, so you can send emails and so on. And obviously, you can see how something like that works really, really well with somebody who's doing that kind of work. It's mobile-centric, so it can also do mobile direct notifications and so on. So SNS is actually an immensely popular service. A huge number of customers use it, and we'll take a deep dive into what it does.
Excellent. Okay, May 24th, SQS and SNS once again, messaging for media and broadcasting. Guests will be Stephen Godwin and Christopher Darliston, both development leads for the BBC. The British Broadcasting Company. They will be dialing in from London.
Now, BBC is a big operation, and this is a big application, but of course, when I think of BBC, I think exterminate. So there you go. So they're the biggest audio and video on-demand service just about anywhere. 1/3 of the country submits, what's this number here? 10 million video playback requests every day. And the service publisher, they do over 10,000 hours of media every week. And they use SQS a whole lot. Back to SQS for a minute. It's the oldest and I think maybe the biggest and clearly the simplest of our messaging services. And it's really what they need for this kind of really, really heavy duty. I'm kind of looking forward to this one because geeks like big numbers, and we're going to have lots of big numbers in this one.
So according to our colleague Trevor, who's in the chat, he said that Stomp is simple text-oriented messaging protocol.
Great.
There we go. Okay, so May 31st, Amazon Pinpoint, and that will be messaging for real-time user engagement. Okay, June 7th, we'll go and talk about the Internet of Things. We'll talk about messaging for millions of devices, focusing on the IoT message broker. Our customer uses the message broker in a lot of interesting ways. Taxi hailing service to send millions of messages between the devices in the vehicles, consumer mobile phone applications, tracking vehicle movement, and the AWS IoT message broker is the serverless messaging infrastructure behind all of that.
That's right. Now, it turns out that the things and the Internet of Things are kind of dumb, and they aren't smart enough to do much computing, but boy, do they ever emit a lot of data. And being dumb, they also don't have really any place to store it, and they certainly don't have any secure, replicated, durable storage. So they got to ship it off into the net as soon as possible, and that's what IoT is all about, is soaking this stuff up and then sending it where it needs to go. It turns out, and this is interesting, that they rely heavily on MQTT, as does Amazon MQ can do that as well. So if people care about MQTT, and a lot of people do, I think we're going to be diving into some of the finer points of what that means and how to use it there in this session.
Okay, June 14th, we'll take a look at Kinesis, and that's our second really big messaging service, I guess, in terms of message volume.
Yeah,
is that the way we like to look at it? And that session is messaging for real-time analytics. We'll be joined by Alan McInnes, who's an AWS solution architect, or SA, as we often say, and he'll talk about one of his favorite customers, Thomson Reuters. They've got hundreds of digital products, and they know a lot about making great use of the cloud.
Yeah, I'm a huge fan of Thomson Reuters. They're doing also super interesting stuff in the serverless space, and they're all about industrial video. You know, they not only publish video, a lot of people do that, but it's news video. So it has to come in and get processed and go out right away. So they apply all sorts of interesting technology. Kinesis is also a fantastically interesting product. It is oriented towards streaming. And when I say streaming, I mean really big streaming. Each Kinesis shard can process a megabyte a second, and there are lots of Kinesis streams out there with thousands of shards. So you do the arithmetic on that. And then once you've got streams, you probably want to do analytics, you want to do machine learning on them, and Kinesis makes it super easy to attach analytics, machine learning, that kind of stuff to the stream as it goes by. And then there's the other interesting problem is as this stuff streams in, where do you put it? And Kinesis also has some really interesting ideas about how you get stuff off the stream and into storage in the cloud.
Okay, now June 21st, last but definitely not least, we're going to wrap up the series by revisiting one of the reasons that we introduced SQS in the first place, to decouple the back-end systems such as the order processing and the billing from the rest of the infrastructure. And we'll be joined by AWS Principal Architect Rajiv Chakrabarty, and he works with some of our biggest customers on integration within their existing IT systems. And he talks about multiple systems, millions of accounts, all using AWS messaging infrastructure.
Yeah, you noticed that a couple of our guests are systems architects, SAs as we say. These people are great. They're the ones who go out there and actually sit with the customer and set our stuff up and get it working smoothly. So often it turns out they know more about how to use the services than people like us who actually build them. And
actually very interesting that we build them, and we start from that blank sheet of paper, we take the customer input, we understand the needs, actually build it, put it to use, but then you sit down with the customer, and the customer has a really distinct and often more encompassing view than we do. I see that happen just about every week when I speak to our customers.
Yeah, the thing is that when you build a product, you have sort of a mental model in mind of what it's for and how people will use it. And the products we build tend to be fairly horizontal and general purpose. And what happens is you get out there and you discover that people are doing things that seem completely crazy. Well, wait a second, that wasn't what we had in mind, but they do it anyhow. And then what happens is these things become best practices, and there's essays out there giving instruction to the world on optimal ways for deploying it, and it goes way past. It's like having a child. You send them out into the world and they do a shocking thing.
Absolutely, absolutely. All right, so let's see. How is our questions feed coming in from here? Okay, here's a good question from Simon. And Simon says, does SQS/SNS lose messages?
They do not lose messages. So the way it works is most of the AWS products that store data have basically the same philosophy. They will go and be stored in multiple AZs, and the typical number is 3 and up copies. And so with these services, when you do a write transaction to us, we don't actually acknowledge the write until it's at rest in multiple places. And that's absolutely necessary. I mean, what business would bet on loosely connecting components with a queue if there was any risk at all that things would suddenly go missing? Now, this being the cloud, there is the opposite problem, which is that sometimes you might get a duplicates. You might put a message in once and it comes out twice, and that's a side effect of the way we store things. You can avoid that by using FIFO queues, which guarantee exactly once processing, but that brings you some constraints in terms of throughput and so on. So there's a lot of trade-offs, but the short answer is no, we don't lose these things.
Good. It's always interesting at the scale we run at that you think about something low priority or low probability, and you assign it once in a million, once in a billion, and then you realize that a once in a billion thing probably happens every couple seconds at the scale that we run at.
Absolutely. You look at we call them the AFR, annual failure rate for servers, and it's pretty low. The annual failure rate for a typical modern server is down in the low single-digit percentage points, which means we have thousands per second, basically, right?
Exactly.
And the services just have to deal with that. And you know, there's also bad people on the internet who are always attacking you.
Oh, really?
And that's right. So it's a lot of work to keep things safe, but it's work that we do.
Okay, let's take another look and see if we have any other questions in our. Let's see. Okay, here's another good one. Which one is good for long polling, SNS or SQS?
Oh my goodness gracious. SQS absolutely supports long polling, and it's a good way to use it. Actually, long polling is a really good way to do it without keeping your network traffic down and your latency down. So long polling, and the SDK does that for you if you use the SDK. But if you're writing your own RESTful calls, you can long poll, and that'll work just fine. I don't think it really applies to SNS, because the idea with SNS is you don't actually retrieve messages from SNS. You send them to a topic, and then you route them to a queue like SQS or to a RESTful endpoint or to email or to Lambda or whatever. And those services take care of the polling and getting them out of the SNS topics and then executing.
Yeah, I generally think more in terms of notifications and callbacks
Right.
than in terms of making a
Right.
function call that might not return for seconds or minutes or
Well, that's right.
hours.
Typically, when you send something to SNS, the result is that somebody gets an email message or a notification on their phone or something like that. Yeah.
Excellent. Okay, let's see. Do we have any more questions that we should? Okay, Adorable Pug says, what am I doing here? We can't help you with that particular question. You're watching two really interesting folks talk about messaging. Anything else? I think that just about wraps things up
I guess
for
that
today.
wraps things up.
Okay.
Well,
Well, it's
Jeff-
been a ton of fun, and I'm going to be sure to tune in for the remaining 5 episodes and recommend our audience do the same.
You know, we used to think that compute was mostly about compute and storage, but I think these days computing is really about compute, storage, and messaging. And you really can't build a substantial cloud notification system without all 3 of them. So messaging is here, and for the next 6 weeks, we're going to be diving deep on it. So thanks everybody for tuning in.
Thank you all.